So I would love to welcome to the stage another topic of reducing. Can everyone hear okay? Is that all right? Is it just me? Okay, fine. It's just me. I'll get over it. Next up, we've got a topic about cleaner clouds, practical tips to reduce your data emissions. So our speaker is the co-founder of Leaf Cloud, which uses server heat to substitute the use of fossil fuels. Nice. That's a kind of meaty solution that I like. Please give a warm welcome to Thatcher Peskins, co-founder of Leaf Cloud. Thank you.
About what the good things you're doing, right? And I'm going to do a news release and make mention of all of you. I could find everyone on LinkedIn.
Can you hear me? Yeah, that's great. Thank you guys for being here. And it was very nice to see this panel discussion just before, because it was so much about sustainability in the life cycle of products and how can emissions be reduced in the products that we use in day-to-day life. I'm here to talk about one of the other things that many of us use today, especially for the people who are attending this conference, which is the data use of your cloud today. And so I want to give you a talk with some context about these kinds of emissions. So what I'll talk about today is what the problem is. Can I see my own slides here? Is that possible? What you can do about it, and the case for Leaf Cloud. So first of all, what is the problem? Well, this is basically the problem, right? Melting glaciers, rising water levels, massive forest fires, like from California to Spain to southern France. Everybody here now is feeling really the impact of the climate change. It's no longer something that is a guess, and we can see that the curve is only going. We're at the start of it. So how is this caused? Well, this is one. These are the windmills, but really behind that is the coal power plant, electricity generation. What you see here on the foreground, this is the data center. This happens to be the Google data center, which is the same one here pictured. And it is just so, yes, they have some green energy that they buy, but really, in essence, they are using so much energy. You see all the blue cooling towers? This is how they heat the sky with the energy of the servers. And so how much do they use? 3.2 terawatt hours of electricity in the Netherlands alone. That's about 3% of the electricity that we use. In context, about 3 times as much as the Dutch railways, or about a third of all the wind energy that we produce. This is also to illustrate the problem that just switching to green energy, like your Azure or AWS or Google might do, is not the whole solution. If they use all of the green energy, then what do I drive my car with? What do I turn my lights on with? This is a real problem that we should recognize that we also need to reduce. So, first, 2 questions. Can I see a raise of hands for people who are doing something in the cloud? Most of you, right? OK, great. So I have questions for you. How much CO2 emissions does a A100 or V100, these are powerful GPUs, cause in a single year? Is that 100 grams? Fingers? Hands? 10 kilograms? Hands? A few hands? Or 1,000 kilograms? More hands? OK. Well, you're pretty spot on for those that were at that end, right? This is massive. This is a 300-watt CPU, or GPU, not counting the server itself. And it would do the equivalent of 10,000 kilometers driving. That's a lot. What is it also? 37 Big Macs, right? This is to make it personal for you. So if you have control to influence how much you're using in the cloud, you can actually make a big difference, right? So I don't have so much time and have a lot to speak about, but I would like to give all of you also some practical tips of what you can do to change. Now, this is a little bit tailored also to people who are actually running services in the cloud. So bear with me, and I'll go fast here. What can you do? It's mostly reduce work, increase utilization, and optimize place and time, right? So especially for those that are making the models, don't train more than you need. I know it's very tempting, I have so much data, yeah, let's just go, 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 go. But hey, there's a price there, right? For the environment as well. Reduce your resolution, reduce your input size, maybe do a little bit less, iterate quicker on smaller sets, and then scale up as you go. More for general services, remove services that you don't use. Build and write it more efficiently. Pick your programming language to be the right one. And do clever caching. Don't calculate the stuff anew if you already knew the answer. Very much so for big data. Then, like, right size your resource requests and limits. This is for Kubernetes, but also applies a lot. Make sure that you pack it in right size. And also then automatically stop staging in test environments. If you leave your servers running over the weekend and you don't use them, they still consume energy. Even if you run in the cloud, whatever you're not using, other people might also not use, and then you might as well just have it shut down. It really helps. Then finally, optimize for place and time. Choose where you run. Many of you don't realize, but the different cloud regions, even if you're within AWS or something, which is not good in general, but they have different cloud impacts. US East, for example, is notoriously coal power heavy, whereas Frankfurt is much more green powered. So pick that carefully. If you're not in a hurry, use a queue. This is for utilization, really bring it up. If you control the hardware, turn on power saving mode, right? And also pick the more sustainable, more power efficient CPU. You often have the choice to pick the instance size and type. Pick it carefully. So this is, again, sorry, I'm going fast. I have a lot to say and not so much time. For this, I also want to make the case for Leaf Cloud. So Leaf Cloud is a cloud infrastructure provider. And we realize that cloud is a huge drain on the available, sustainable energy available. But cloud also enables developer productivity and innovation that would not otherwise be possible. Many examples here at the conference are, okay, what does AI enable? Many things, including sustainability benefits. And so we try to change the game by making both of these possible, by changing the design. So this is the old situation, a data center, where we have servers in a big box heating the sky, where coolers chill the air and then move it up in the air. We change that by making it in this way. We move the servers into the basement of that apartment building, where we actually heat the tap water of the entire building. And in doing so, reduce the gas that the apartment building would otherwise use to power the building. And we focus on tap water because this is used year-round. So even in summer, we can actually deliver that energy efficiently. So what are then the emissions per kilowatt per year? So 1 kilowatt for an entire year. A normal data center, and I picked an energy mix, like 30% green energy, what is typically used. This causes 3,500 kilograms of CO2 emissions in a year. But then next to it, there might be an apartment building that also for 1 kilowatt of heat, they spend 2,300 kilograms of CO2. Now what does Leaf Cloud do? It says, no, look, we use green energy, solar powers, locally sourced, Dutch, fully proper. And in doing so, we also eliminate this offset. So in the end, what you see is that if you calculate that, we are there for a carbon negative cloud. And so my point is, if you were then to have resources in the cloud and you are doing GPU workloads, other things that actually generate a lot of heat, then pick your place well. So how do you do it? It's one of the questions I get a lot, so this one I'll start answering. If we put servers in the basement of an apartment building, you also want to have reliability, durability, safety, security, all these kind of other requirements still met. So for that, we built a distributed data center, where in the core we have our storage clusters, and around that we have a number of leaf sites. These are these buildings where the heat is actually being reused. And the connection is like this. The storage clusters, the hard drives, are in the data center, and at the leaf site, we run the compute. Between that, we have our own managed dark fiber connection, which means we have our own optics, which means that we can do extremely low latency and very high throughput. Also make the distance not too big, like 10 kilometers or less. And so like 0.1 millisecond is the latency round trip between these. So we can actually do these kind of really cool things. And so therefore, if a site would fail, we can simply move over the server to another place. Here, actually, I'd like to stop for a question, and maybe one or two. Anyone wants to know anything about this? Or about the energy-saving parts before? Let's see, there was a microphone, but I can also repeat your question if you just ask it.
Very low level, like how do you prevent people from going into the servers and looking at what's being computed?
So your question is very low level. How do you prevent people from going into the server and seeing what's being computed? Very good question. So what we do is that in this architecture, we use full disk encryption with a system called LUKS, which means that the kernel on the server decrypts the disk on this machine, and the moment it goes to the storage, it's already encrypted when it goes over the line. So then, when you tap on fiber, there's nothing to be found. But also, since we don't actually have any storage on these leaf sites, even if you would steal all our servers, there's nothing to be stolen, not of your data at least. We'll be sad because we lost a lot of expensive hardware, but none of your security was compromised. Any other questions? Sir, in the middle?
When you use Azure, you also benefit from a lot of services from Microsoft. Is it possible to put the Leaf Cloud below Azure, so to say, to benefit from the
Maybe you can ask the question with the microphone again, sorry.
When you use Azure or Microsoft or Google or whoever, you use a lot of services that they provide. Is it possible to use the Azure services while using Leaf Cloud as the low-level infrastructure layer?
Very good question. So the question is if we can use other infrastructures, if we can use our infrastructure in combination with Azure. The answer is actually yes. We've actually recently been doing a very interesting use case with an enterprise where we use Azure Arc to control the access to a Kubernetes cluster running completely on Leaf Cloud. And then you get all the robust access control, Azure Active Directory integration and so forth, readily available to actually connect that, and then you get kind of the best of both worlds. And since we are a relatively small company, we can also help you design solutions that make that like connections possible and so forth. So yeah, there are solutions towards that effect. Thank you. Do you mind if I keep your question just for a bit? I'll finish the presentation, and I'd love to take more questions. Because I have just 2 more slides or something. Just a bit about use cases. We do many different things, but Kubernetes is one of them. But the second one here, like we also have a booth, but like the AI and machine learning are a big use case because, again, as I illustrated, these GPUs are super power hungry. And actually doesn't really fit so well in other data centers even. But also high performance compute, CI/CD, web application hosting, and image and movie transcoding are things that we do. And so what we offer is just servers, storage and networking, Kubernetes, object storage, load balancers, which are scalable and programmable. So much for the sales talk, but like I would use it to illustrate that yes, we save a lot of energy, but also just offer a platform that you can use. So yes, please, your question.
About the summer.
About?
In the summer, when you don't need the apartment building to be heated.
Great question. So what do we do in summer? We actually focus on the tap water for the servers. So the servers, they feed a boiler that is used for the tap water system of these apartment buildings. We are very picky on which apartment buildings we pick, namely those that have one of these central heating systems. And we do that so that we can actually have the most energy saving potential year round. I'll close here with a thank you for sure. Maybe any other questions? I'm also still open for. I have like a minute left or so. Sir on the left.
why do you go for this distributed setup when you can have a centralized server and still do this, delivering of the heat through maybe something like a district heating, something like that? So why did you end up with a decentralized process? Because that might be a bit more complicated to implement for a data center.
Yeah, great question. So why do we have a distributed setup instead of like delivering heat from a data center? The key difference there is that it's very inefficient, no matter how you do it. Most of the heat nets are high energy, high warmth heat nets, like 110 degrees Celsius, what they need as input heat, and then they come back 80 degrees Celsius or something, which means that a data center, which in the rooms make kind of at best lukewarm air, like 20 to 30 degrees Celsius, they would have to bring this temperature up to 120, where you already lose all the efficiency, and then move it across kilometers and then bring it back. So then you would need to have low heat nets. They are very expensive to install because you need massive pipes over long distances. And even then, there's so much loss in that data center kind of there already that we really figured it's so much smarter to put it there where you need the heat. And we proved that it's not actually a hassle. And as a side effect, it also saves a lot of money because then we don't need to build the data center in the first place, don't have to build the cooling because we get this for free. Do you have time for a last question?
No.
Okay.
Thanks, everyone.
Thank you so much.
Well done. Excellent. Thank you so much.